noticed that none of these projects work very well in this class. All the emulators don't work too well. All the proxies don't work too well. It's pretty frustrating, but it could be worse. That's why I wanted to demonstrate this one, and it's only going to be extra credit when I put it up because it is so flaky. It depends on which version of the Mac OS you have, which version of the hardware you have, and everything else. It is seriously unfriendly, but it's very useful when you get it working. So, all right. Let me mute people so they don't annoy each other. All right. And I would turn down the sound. All right, there we go. All right, so let me just open a new window here and let's see if I can get this thing to go away. There we are. All right, so we got a couple of minutes yet. I'll see if there's any exciting news. I saw a lot of stuff, but it didn't seem too important. That looks awesome, but I haven't got it working yet. You can supposedly take over Joomla in a few seconds. I got to set that up and see if I can make a project out of that. And this one, there's several things I saw today that are going to make awesome projects. If anybody wants to get them working, like this one's great. Snapd. I wondered what Snapd is. And Snapd, you see it in Ubuntu. Snapd is, I thought it was just for mobile devices, but what Snapd is it distributes applications with all the libraries for once, which is, you know, Ubuntu finally catching up with Windows. Because as you probably know, whenever you install anything on Linux, you then spend the next 2 hours trying to hunt down why it doesn't have the right version of 10 things you can't find. And apparently somebody else got fed up with that. So that's what Snapd is. Snapd installs software with all the libraries, which sounds good, but they configured it wrong. So you can take over the machine through it and escalate to root, which is bloody awesome. So it sounds very easy. There's a REST command, and you just have to send it a malicious REST command and you become root. So I got to try that out. That's awesome. That should affect all my servers, by the way. You should totally be able to escalate yourself to root on all my attack servers. And you should, yeah, you should be, if you figure out how to do this. If you do get it working, I'll make a homework project out of it. Oh, and this has happened to me before. I've turned on some kind of feature that draws on the screen, and I don't know how to turn it off. That had happened to me before. I think it's something in Zoom. Zoom has some stupid Blackboard feature or some garbage that I turned on by accident. If anybody remembers, some student figured it out last time. How do I turn off this garbage? Everybody adds features to their junk that I can't turn off. Anyway, if somebody figures out how to do it, escape or something, it's never anything easy. I think last time this happened, some student Googled and found out how to turn off this stupid Blackboard thing in Zoom. Anyway, good, maybe someone's got it. Is anyone else having trouble using Genymotion with the certificate on HTTPS? If you're using Windows, they have great trouble. If you're using a Mac, probably not. And by the way, that is something in 2 minutes, I'll talk about that. I'm glad you reminded me. I should talk about Windows users. All right, let's see. Linux, it should work fine on Linux. I've done it for many years on Linux. But all this stuff is pretty flaky. There are no guarantees. If you bring it into the lab, I can help you set it up. But it is quite a struggle. Anyway, I think I've got a minute or two. Let's see if there's anything else exciting in the news. There are a lot of vulnerabilities that would make good projects, but I haven't had time to make them into projects yet. The Snapd one looked good. And yes, this one, Windows DHCP server, remote code execution, scored 9 out of 8 out of 10 in severity. So apparently you can just take over Windows machines through the DHCP. That sounds bloody awesome. Be fun to get that working. There's a escape from Docker that we spent time trying to get working last night or night before and couldn't quite get there. But I think that'll be out soon. I think that one has been known in secret for about 2 weeks, and they've been patching it, and the experts have not reached the date when they'll release their code yet. So I think pretty soon we'll just have code that's released that's click and play after they believe everyone's had their chance to fix it. And Governor Newsom canceled the high-speed rail or cut it back, and he thinks that he can get all the companies to pay you for their data. So this reminds me of lies politicians tell. Oh, well, I heard the chancellor thinks we're going to have enrollment go up next semester, so he doesn't have to cut so much because firing a lot of the teachers and canceling most of the classes is somehow going to make enrollment go up. But it seems to be a necessary job in politics to say something that is obviously a lie and everybody knows it's a lie, and they just pretend it's true. I think it's something to do with comforting people. They don't want the truth, so you tell them a lie. Everyone knows it's a lie, but you all pretend you don't know, and that's how you get through things. Anyway, so I don't think this is going to happen. Google and Amazon and everyone are not going to pay us for our data. And I don't think anybody believes that. I think he just wanted to get some applause or something. Anyway, so we're up close enough to the real time. Let's talk about the project. This is 128. All right, in the past, I've told people just forget about using Windows in this class. But now we're more emulators than I knew about in the past. And it is possible to do some of this stuff on Windows. So I'm trying to make a Windows track because I'm planning to teach this class in Vegas and China and Illinois and Indiana and just everywhere. And I don't want to be limited to that, so I'm trying to make a Windows track. So far, there's a Windows version and a PC version of these, and I'm going to try and keep it up. So you can do some version of all this on Windows. You do need a lot of emulators. Genymotion works a little bit on Windows, but a lot of things don't work. What works better on Windows is BlueStacks and Knox. And they're different. And some projects work on BlueStacks and some projects work on Knox. Anyway, among them, I was able to get a lot of them working, and I'll try to have a complete Windows track there. The numbers are all sort of crazy on the Windows side, but you can't have everything. And if you want to, you can do them both. You know, the ones that have extra numbers, all the extra ones, you can do them, and it's fine if you want to. But anyway, these are ones I've actually got working on Windows. So a lot of these actually work on Windows too. I haven't got there yet. Anyway, so let me talk more about Burp. Or I mean about Android Intense, and then we'll do the thing which I told people bring. I hope people brought their phones with apps on them to test, because I'm all set. And when I did this before, this is how I got my class. This class banned in Texas. The students brought in apps and tested them, and we found that college's app had a vulnerability. So they tried to throw me out and cancel the class and blacklist me. And all the students said they would leave if they did that. So they rebelled, and they decided not to fire me after all. But more later, when I have the recording turned off, I'm about to do the same thing again. I've got another job, and I'm about to lose it for doing the same thing. Because the very first thing I did was test their stuff, and their stuff is broken. And sometimes people don't like to hear that, but they might as well not hire me if they don't want to hear that. Anyway, so,
what do you do, go tell them?
I haven't tried that. That would probably be more professional. If I actually wanted to keep the contract, I would not tell them about their problems and wait and find out what they want to hear, but I haven't been doing that. I must have a bad attitude. Anyway, so yeah.
Old and bitter.
That's it, old and bitter. That's it, exactly. You got it. So, and it suits me just fine. I totally turned into my father. And when I was a kid, I said, I'll never be like that. And now I'm totally like that. But what I hadn't realized is it's pretty good when you're inside. It's just being outside that looks terrible. Anyway, so, anyway, that's what Mark Twain said. You know, he said, when I was 17, my father is the biggest fool I ever knew. And when I came back 3 years later, it's amazing how much the old man had learned in 3 years. And, you know, now I understand my dad a lot better than I did when I was a kid. Anyway, so if somebody figures out how to get rid of the red mark, that would be nice. But anyway, we'll just live with it because I'm too lazy to go Google how to turn off the stupid advanced features in Zoom. Anyway, so we've been through the first couple of things here, and now we're down to the last bit, the security model and reverse engineering applications, which is what you've been doing in the projects. That is the main thing we're doing in this class, is reverse engineering application. That's what I'm naming the workshop. There are other things you can do in Android, but that's the main thing we're focusing on here. And it's good fun. I'm planning to keep it up. We're going to talk about generic exploit mitigations, and these actually are all the topic of 127, a different class. That's really what's going on tonight. 127 is where you develop exploits, and Android is the same as Linux, and it has the same defenses, essentially, as Linux. And we spend two whole classes. We spent a whole class on Linux defenses, pretty much as 127, and a whole class on Windows defenses is the malware analysis class, and that's essentially what they saw there. And the point is, you can patch your code and train your developers to write better code, and that would, of course, be the nicest solution, but most people don't have that luxury. You have stuff like commercial products and stuff previous generations of developers have written that you have to use, and you wish you could do something to be in less risk, even though you're using old buggy code. And that's what these mitigations do. These mitigations attempt to make it less dangerous to use old buggy code. Of course, You can't remove all the danger, but you can lower the danger, and we'll talk about that. So these are the generic exploit mitigation protections. So what you can do, and this is really kind of a tall order, you want to change the way the operating system runs so that it no longer permits old attacks to work, but you also don't want to break the operation of applications that were written to run under the old system. So it is a balancing act. And in the Microsoft Windows world, they make a big deal of giving you choices. You can turn off all the mitigations to run your old horrible stuff. If it's written badly enough, you have to turn everything off. But if it's not quite so bad, you can turn on some of this stuff. And there are various adjustments of how many of these mitigations to turn on. So anyway, stack cookies is a big one. Been around for about 15 years in many versions. This is where you put a special random number at the end of the stack frame for every call you make, although in Windows anyway, it actually doesn't put it on every call. It analyzes the call to decide whether this function looks dangerous and only turn on stack cookies if the function appears to do something like have strings or take user input or something. Because I guess it doesn't want you to incur the performance penalty of adding it everywhere. Now, I'm not sure if Linux does it that way or not. But anyway, stack cookies put a mark at the end of every stack frame so that if somebody overflows a variable with a lot of extra text and tries to change the return pointer, it won't work. And this ended the classic buffer overflow exploit that Aleph Null published that almost everyone does, and we spend half of 127 doing. This is the fundamental attack that created the modern world of hacking, where you can just put something in a string variable and take over the machine, and this defense stops it almost completely. So that's good. Then there's ILP. This is for integer overflows. Integer overflows are not as common as stack overflows, which were the #1 kind of exploit everybody used everywhere, but they happen pretty often. And integer overflows are where you have a number that gets too big and it rolls around and becomes negative or turns 0. So you can put in, you have some kind of length limit, and by exceeding the length limit by a small amount, you wouldn't make it, but by exceeding it by a ridiculous amount, like 32,000, you get through because now it interprets it as a negative number. So there's a mitigation to try to prevent that. Then there's Malloc and Calloc extensions. If the stack is used for local variables that you retain during one routine and you discard when you come back, but there's other kinds of data that comes into your application, like steady streams of data, like network packets. You download a file, you process the file, you throw it away, you want to make room for the next file. For that, you use the heap. The heap is where you have chunks of space you allocate, use, and then deallocate. And everybody has to use the heap extensively for any large amount of data, or you'll use it while it's getting in the machine and crash. But that is pretty dangerous. And that's what goes on here. One of the most common problems is double free. If you free the same heap chunk twice, you take numbers that could be under the attacker's control and do writes with them, and you can take over the machine. Another common thing is that you don't free something when you should, and you end up with a dangling pointer pointing to a piece of memory that is no longer being used for that purpose. And again, you can write to something you shouldn't write to. And if you manage to write to something that ultimately goes in the instruction pointer, you can take over the machine. I see a chat message coming in. Yeah.
How is the double free the problem?
Oh, yeah, we do it quite a bit in 127. The double free is a problem because if you free memory, let me just see if I can do something for the people that are remote. Now I kind of wish I had that drawing thing. Let me see if I can make some kind of diagram. Let's find some kind of application that will let me do it. That's not going to do it. Well, let's see if I can do it here.
It says like annotate.
What's that?
It says like annotate.
NSA, you say?
Annotate.
Annotate. Oh, there's an annotate up here somewhere?
Yeah, it's on the top. Like,
Text. Wait, that's not the right app. Probably this thing. Oh, there's a chat coming in. Well, I'll try to answer your question. Let's see, chat. To remove the strange mark, click annotate and clear. Thank you, good. All right, now I wonder if I can actually use it. Zoom, where is annotate?
Right
Up here. Annotate, oh good, thank you, good. Good, I appreciate it. Then there should be clear, thank you. All right, clear all drawings, good, thank you. Now, anyway, now I seem to have it back again, but actually maybe I'll use it. If I can't figure out how to turn it off, stop. That doesn't turn it off, close, this closes it, okay. Anyway, maybe I'll use it. If I can actually draw something here, I can get a white background with this thing and annotate. Can I draw? Sorry. So, oh, good. Okay, so here's how the heap works. You have a chunk of data, and you have another chunk of data, and another chunk of data. That's just what I wanted, actually. Okay, good. So now, the way the heap works is it's a linked list. You have a chunk of data, and it has a forward pointer to the next chunk, and it has a reverse pointer. And this one has a forward pointer to the next chunk. Okay, so now if you're storing data in here, and then you're done storing data in here, you try to delete this. That's what free does. And when you free it, it has to fix these pointers. So this pointer skips over that and goes over here. And what that means is you write data here that points to a new address, and the new address you get from here. So if I was able to overflow this and change the contents of data here, and then free it twice, I'm either able to overflow it, or if you free it and then free it again, you end up doing a write operation trying to fix those pointers, and that write operation comes from data I can put in. That's what happens. The result of a double free, or a free with an overflow in the size of a link of a chunk in the heap, is you get a write operation, and I get to control what you're writing and what address it goes to. And if I can permit a write operation in RAM, I can take over the machine. We do that in 127 because I just have to write to a location that will ultimately control the operation of the machine. And there are quite a few of those. We'll talk about some more coming up later, like the pointers to system libraries. So anyway, that's good. Great. Maybe I'll remember this annotate thing. It's less than useless. Anyway, so there's a way to clear it. Yeah, you free it, and then if you free it again, it does another write operation. And it's getting data that is no longer what it should be. And under certain conditions, you get a chance to change that data, and the second free then turns into a write you can control. So I don't know the exact details, but I do know that's the general feature of it all. Now I'll clear it here. Good. And clear all drawings and see if I can turn this off. Okay, well, maybe I'm going to remember this. That's all right. Good. All right. So that's what these extensions do. These extensions try to improve the allocation process to prevent this stuff. Microsoft has a ton of mitigations, and they keep adding more and more heap mitigation because it turns out to be very dangerous, and there are tons of heaps. And they get smarter and smarter about checking every operation on the heap and making sure you're not doing any of the many attacks. Anyway, then you got format strings. Format strings are amazing. Because C has this ability to print, you're supposed to give it a format of how to print, but you can actually print without specifying the format. I don't know why they even allow you to do that, but you're allowed to do it. And if you do it, if I can put a format statement in the data, it will interpret that as a format statement. So this amounts to sort of like SQL injection. I'm supposed to be just giving you data, but part of what I can put in actually turns into something active. So it turns out that you can do arbitrary writes this way. It is, it's a very strange feature of C. I don't know why they allow it, but anyway, what is amazing about it is it's incredibly easy to fix in the source code. You just need to grep for a print statement that doesn't have a format. It's just a pattern, printf, only one thing in there instead of two things. But if you don't, this is one of the defenses to try to stop it. It's a very fun vulnerability to attack, very easy to exploit. Anyway, NX is a big one. This was another mitigation back in the days of Windows XP. Starting long ago and all through Windows 2000 and Windows XP, everybody did buffer overflows like crazy. It was 80% of all attacks. You take over machines right and left. And when Vista came out, they were all gone. And for a whole year, and even none of the white hat hackers could take over Vista because they turned on NX and ASLR. These two defenses stalled the white hat community for about a year. They went to the Pwn to Own contest and nobody could take over Vista at all. They gave up and they went back to XP for 1 year. It took a while. They eventually found ways to get through them, but this is really powerful. NX is a property on the motherboard. It's been around for more than 10 years. You can put permissions in RAM. Normally people don't bother, but NX allows you to mark RAM non-executable, and that's what you should do to the stack. The stack contains data that came in from passwords and user input, and it shouldn't contain code, so you mark it non-executable. And then if someone tries to perform a buffer overflow exploit, they can inject code, but it won't run. It'll just stop as soon as you try to run code in the non-executable section. That's very powerful, and it ends a whole generation of attacks. Address space layout randomization is also very effective. This means you relocate every module to a random location in memory every time you start it, or it should mean that. If you did that, then the attacker could not find the code they injected. This doesn't stop them from doing the attack. It just means they have to try a large number of times to make it work. So if this turned out to be very effective in practice, but it's a whole lot less effective than it should be because they don't actually randomize it very well. In fact, in Microsoft Windows, they only have something like 10 bits of randomization. So it only has 1,000 locations. So if you just run the same old attack more than 1,000 times, you'll just get lucky. So that's pretty pathetic. And the other thing that's pathetic is they don't actually apply this to every module. A bunch of modules are not randomized. So all you have to do is attack them. So it's kind of rude. It's like very many defenses, like ProGuard we'll see in Android. It's like a security guard that locks half the doors and goes home. You haven't really accomplished very much. But anyway, this is the partial ASLR, and you can have more ASLR if you have position-independent executable support. That means all the executables in the machine are able to be relocated. And that makes it easier to provide a randomization. Of course, the reason they don't randomize everything is because there are some system processes that are difficult to randomize. And anyway, then there's relocation read-only. This hardens some data sections, again, by making some things read-only. And what you're trying to do here is stop those overwrites. Remember, I said about the heap overflow that the main consequence of a heap exploit is that you get the ability to write a byte to a word to memory location. But how do you take over a machine by writing? What you typically write to is the global offset table. Every time you call a C routine like print or scan or anything, it goes to a global offset table, which then points to another table on the system side, which goes to the routine. There are two layers of indirection. And if you change the values in the global offset table, you cause it to misunderstand what the next print is and do something else instead. So writing here is a common way to take over the machine, and here they make it read-only. So you can't write there, which would stop those kind of attacks. We did quite a few of them in 127. And here's something that Microsoft really got into. I don't know exactly how the Linux version works, but I know this was the main thing Microsoft said they did to improve their operating system between Windows XP and Vista, was they rewrote C. They made special libraries for C. C is the source of almost all these problems. C has about 10 or 15 extremely dangerous functions like string copy that are responsible for all the buffer overflows. And what they did was they wrote a library that automatically removes those dangerous functions and produces dangerous features from the others. So your developers have to quit using them. And that's what Microsoft published those libraries, and they say, here's the safer version of C that we think everybody should use. And that's kind of what's happening here, replacing C functions with less dangerous functions. Like C has this unfortunate thing where strings don't tell you how long they are. Strings are supposed to have a null pointer at the end, and the string just goes until it finds the null pointer. So this means very often you copy a string into something and you don't know how long it is. And what actually goes there is a different length. So you end up with all these overflow problems. And if you use string ncopy, every time you copy, you give it a number, which is how many bytes to copy. So you control it, and you're reminded that you always have to tell it how many bytes to copy instead of assuming it will correctly find the end of a string, which is what leads to a lot of the problems. And similar updates in these functions make it much less dangerous to use C. And SELinux is really big. I've been confronting this for the last 5 or 6 years because I keep using the latest version of Ubuntu and then trying to put up vulnerable code, and it's harder and harder because this is security enhanced Linux. It was designed to meet military specifications, and what they did basically was add a whole bunch of extra security measures all through the operating system, like extra firewalls. So if you try to do SQL injection, it turns out that the SQL process is not allowed to write to certain locations. It's not just permissions of the folder, it has another thing wrapped around it that says this process can only do this and can only do that. There's another layer of permissions. And there are many other such things. This came out that if you have the Docker exploit that came out this week, where you can escape from a Docker container and run on the host, they say if you had SELinux properly configured on the host, it would have saved you. It is very annoying, though, to set up like group policy. It reminds me of Windows group policy. You have all these extra settings, but you have to understand them and set them correctly or they don't do you any good. And it's a lot of burden. And then a lot of things you try to run won't work anymore, and you have to understand why and turn it off. So it's a lot of hassle. Sort of like firewalls are a lot of hassle. All right, so that's SELinux has 2 modes. This mode just detects violations and logs them. This one actually enforces one. That's the one that's really annoying. Then you really better be good at tuning up your SELinux or you're going to break the server. All right, and then we got more fortified. Now, there's a bunch of mitigations in the kernel too. Now, those exploits apply to general takeover of the machine. The normal takeover, you attack something like, say, the web server, and the web server on a Linux machine is running as the account www data, if it's Apache. On a Windows machine, it's running as iuser _ something or other. And those are low privilege accounts because everyone got tired of running web servers as root, and then when people hacked the web server, they got root. So now there's 2 steps. First, you hack a existing process, which is almost never root, and you get a low privilege account. Then you have to escalate to root. And that's what kernel protections try to stop. In order to escalate to root, you have to defeat the kernel, because the kernel is what specifies who you are and what you're allowed to do. And you have to somehow trick it into letting you change to someone else's identity, which is far easier than it should be. They're an endless chain of kernel exploits. Every 3 months or so, they come up with another one. So you really have to keep everything up to date, or there will be a known kernel exploit. But here's some protections to cut down on it. Getting rid of setuid programs is a very good idea. Setuid programs are the ones which run as root even when you are not root. And in general, in Linux, there's about 10 of them you need, and sloppy programmers make more, because if you're just sloppy, you just open all the permissions, full control to everyone just to get the job done, and you say, well, I'll fix that later. And so they finally just took them all out entirely, removed them all out, and they found some alternative way to do it, which is pretty cool. So that would be nice. To have less setuid programs, that's less attack surface. So then there's the issue of rooting. Anyway, how do you get root on your Android? Now, the original iPhone ran every process as root, but there were no apps and no app store. It was just a phone, like any other phone, that just did what they put on it when they sold it to you. You did not add any code at all. So they figured it was okay to just run everything as root. But when you start having an app store and a web browser and all these things where people are putting in stuff, you don't want to run as root anymore. So Android and the iPhone do not give you root privileges anymore. You're running with a low privilege user, and you do not have root permissions. So that's fine for most people that just want to use the phone, but if you actually want to hack the phone, then you want to be root, and you need some way to do it. Now, jailbreaking iPhones requires an exploit, and Apple is very vigorous about patching them, and you can't get them anymore for less than $1 million. The last several versions of iPhones, there are no known public jailbreaks. But Android is not that secure at all, by design, really. It's not really. They don't really want to stop you from getting root on your phone. They just want to prevent criminals from getting it, and people do it by accident. So there are ways to do it. Basically what you want to do is you want to add an SU binary. So you can do switch user to root under certain conditions, and then you can run as root. That's your goal. You want to add SU, and SU should run like an SUID program so it can escalate you to root. It's going to be one of these SUIDs, so it'll have RWS instead of RWX. S means special permissions, that's the setuid bit, and that means if it's owned by root, it will run as root. The X is on the right, meaning that other people than root can execute it, but when they do, it runs as root. This is how you escalate, and this is how you do things like change your password. In order to change your password, you have to write a hash to the system password table on Linux, and you can't do that without being root. So the password command is an SUID command on Linux. In Android, there's not an X password table. They use some other system, which I don't really understand. I was surprised when I didn't find it, and I Googled it, and they said, yes, there's some other thing like a database or something used that is not as simple. But anyway, so if you want to run this, if you do manage to put SU on the machine, now how do you control it? In Linux, it asks you for your password when you do sudo. Then you have to put in the administrator password. That's also what Windows does now, ever since user account control came out with Vista. But on Android, asking the user for a password is very burdensome. So what they do is this. They just pop up a box saying, someone has asked for root permissions, deny or grant. And that's the equivalent. This is what's considered reasonably secure rooting of your phone, where not just everything runs as root, but you can run things as root when you give it permission. All right, so here's the ways you can do it. You can find an exploit, which means an error made by Google in the kernel, or you can use an unlocked bootloader and replace the firmware on your phone the same way you would on a router. I mean, if you brick your phone, usually by trying to do this, but perhaps due to something else like a hardware problem or anything else, you might need to replace all the firmware on your phone, and you can do that, just like you can do it on a router or anything else. You can boot into a special mode and restore the firmware, and so you can restore it with hacked firmware. So Jailbreak was one of the first ones. There was a volume daemon that mounted the volumes in Linux, and there was a way to trick it into mounting something so you could escalate yourself to root. They were able to write to the global offset table by mounting something. They were able to mount kernel memory in user space and write to it from user space. So since they could write to it, they could write something that took over the machine by changing the global offset table, which we talked about before. If you change those pointers, then when system calls are made to system routines, they go somewhere else. So you can get a process that runs as root and trick it into running your code as root. So this was a bug in Google's original Android. So this affected essentially all Android phones of these old versions, 2.2 to 3. That was Jailbreak, one of the first famous breaks. Then there were a lot of other bugs that were exploited this way. XASLR was a bug in a driver used by Samsung and only a few other devices, so it didn't affect all phones, but it did affect some of them, and you could escalate the root with that one. Yeah.
It's a dumb question, but keep on talking about jailbreak.
Yeah.
What exactly is that?
Actually, it's a very good question. There are technical terms here. Technically, somebody could correct me if I've got a phone hacker out there and correct. I think a jailbreak is when you don't get root, but you disconnect it from your carrier. So you can move from like AT&T to Comcast. That's a jailbreak, and that's what Obama, at the end of his term, he declared that jailbreaking is legal. Because people would lock your phone to one carrier, and they would make you lock you in a contract and say it's illegal for you to move your phone to another character. And he said that's abusive.
Or to be able to do it and not.
Yes, he said you should be allowed to do that, for example, by going into the company and saying, I want to move to another carrier, but it should be legal to jailbreak your phone, which means escaping the restrictions tying you to a carrier. A separate issue is gaining root privileges on the phone so you can install software. That's not necessarily the same thing, although people often do both of them. And that is getting root. And that, I think, is not legal, which is an interesting statement. In fact, it might not be illegal on Android. What happened here is this all dates from the Clinton administration, the Digital Millennium Copyright Act, when they decided to, until the year 1999, you couldn't do financial business on the internet because there was no way to get anybody to sign a contract except with a piece of paper and a pen. And if you got them to check a box on a website, that didn't count in court. So if you were to do a business transaction, they could just not pay, and you couldn't take them to court and demand it because that wasn't as good as a real signature. So this was a huge problem because everybody wanted to do banking on the internet and it's real estate and everything else. So Clinton passed the Digital Millennium Copyright Act, which specified what a digital signature is and gave it rights, but it also specified intellectual property rights. So now it was illegal to take somebody else's software on the internet and make unauthorized copies of it. And that law said you are not allowed to reverse engineer things. You're not allowed to steal the code out of them. You're not allowed to make extra copies or modified products based on copyrighted products. And this means you would not be allowed to root your phone because the phone is proprietary software from, say, Apple, and it's illegal to figure out the cryptography and reverse it and modify your phone. But there is a special deal in the Digital Millennium Copyright Act, or one of the related laws, where you can declare an exception. Once a year, you get a chance to go petition for an exception, and then you get a 3-year exception. So every 3 years, the rules change again. So the first time I taught this class, it was legal to root your phone, but not legal to root your iPad. Next time I taught it, it was the opposite. I don't know what it is this time. I forgot to worry about it because I'm only doing Android. And I believe it's never been illegal to root Android because Google doesn't care, but I'm really not quite sure. And besides, since I've been in this business long enough, I met with the Department of Justice people and everything else, and I found out that everything we do is illegal. It is the illusion that you can do any of this stuff and be 100% legal I'm past it. That is really not true. And so, unfortunately, everything we do is sort of a gray zone where it's not really a matter of being 100% legal. It's a matter of, is this something anyone really cares about? Which I'm afraid is exactly the same as it is in China. I've heard this. If you go to China, you can go to a chat room and start criticizing the government and nothing happens. Then you do a little more. And after they get mad enough, they shut them all down and lock up people. And then you panic and then you start creeping forward, doing a little more again. Nobody knows where the line is. The line is not clear. And that's true of all this stuff. So I don't know. Anyway, but it is a big issue. Jailbreaking is apparently completely legal. That was Obama's contribution. Jailbreaking is okay, but rooting your devices is another issue. And I don't think anybody cares about Android, but the iPhone they totally do care about. Anyway, although I haven't ever heard of a consumer being punished for rooting their individual device, but they did go after GeoHot, the guy that rooted the PlayStation. And they punished him, and this led to the huge war against Sony, where everybody hacked Sony to punish them. Technically, he was breaking the law by writing an exploit and putting it on the web so other people could root their PlayStations. And the PlayStation people felt like, why can't we root our device and use it? And this goes all the way back to analog phones. When I was a kid, you had a phone which was a big chunk of metal with a plastic thing, and you didn't own it. It was owned by the phone company, and the reason was they were afraid that you would modify the phone and send electric surges down the wire and break the phone network, or that's what they said. So you were not allowed to tamper with it. It was illegal to tamper with the phone. It was not your property, and that has continued to this day. Technically, you don't have full control of your Apple device. It's a phone to some extent, and therefore you're not allowed to just take it apart and mess with it without breaking some law. And the battle goes on. There's a whole bunch of people with the right to repair and the right to hack that think you should be able to take apart your car and your phone and everything and modify them all you want. And there's a bunch of people that say, no, that's connected to a critical government infrastructure. You might mess it up, so we're going to lock you out of part of it. And there's no clear line. It goes back and forth, and case by case judgments are made. So anyway. It's an important issue. I'm glad you brought it up. It hasn't come up yet in this class. As far as I know, what you're doing is legal, but I can't swear that it's 100% legal. Certainly running a simulator, well, it might even be illegal to run the Genymotion simulator for all I know in some technical detail, but certainly no one's going to punish you for it. Anyway, so then Samsung had another bug here where you could, if you had a crash, it would write a dump file. This is something that came up in a previous class. We talked about the dangers of log files. So if you write a dump file, it probably writes it with root privileges because the main process has crashed. And it turns out when it writes the dump file, it then also can write a log file, and it turns out you can change where it writes to. This is a fairly common exploit. So you can cause the dump to go to an unexpected place. So what you have to do is cause the dump to overwrite a system file that controls the permissions, and then you take over the device. That's one of the common kind of tricks. Anyway, then the Ace Iconia had an SUID binary with a code injection. They wrote their own and rewrote it wrong, like most of my code is written. So it had code injections. Last time I did red versus blue, it was too easy. So one of the students finished doing the project, and then he hacked the scoring engine because the scoring engine is just completely sloppily written. The only thing I've seen written as badly as my scoring engine is the Genymotion app. Holy cow. That thing is written like by an idiot in 1989. It's amazing. Same way I write code. Like you didn't even care and you were just trying to do it as fast as possible. It's got Shemode 7.7 all over the place. It's just, I didn't believe anybody would really distribute anything in that condition. I do that stuff, but I don't hand it out. Anyway, then there's the master key vulnerability we already talked about. You can take a signed binary and you can add more binary to it, and it will still accept the old signature because it only checks the first file by that name. So this is an exploit that I didn't think of before. You can take a system binary for part of the Android operating system that installs as root, take it off, add more code to it, and put it back with the old signature on it. It will still be valid. So it will accept it as an official Android update because of this vulnerability, and now it installs your stuff as root. That's pretty awesome. Of course, this has been patched, but this does work on Android versions up to 4.2, and that was, again, a bug in Google's whole logic system. These are the most fun bugs. Dan Kaminsky found a few of these. These are bugs that are not exactly errors. They're like design flaws. So it's not like one bad line of code. It's the logic is broken. Those usually are much more far-reaching and powerful. Then there was Chell root. This sounds a little bit like Dirty Cow. If you have multi-threads writing, you can cause them to get confused about who's doing what. There are a lot of race condition flaws like that, and that was another way that rooted many devices. And so then the other way is the same way we've done it with a lot of, this is mostly what you do in the Internet of Things. Hopefully, well, looks like we're not going to be able to keep Elizabeth around all these cuts go through. She was going to run a hacking class. She's really good at hardware hacking. We don't have anybody else with that skill. I don't, that's not my thing. But then hardware hacking, you take these IoT devices like your smart light bulbs and in cars and everything, you attach a JTAG to it, you suck off the firmware, you take it apart in Kali with binwalk, and then you analyze it like these Android things, and then you put back the hacked firmware. I used to do it to floppy drives, and we did it to routers and stuff upstairs. I've done a little bit of it, I'm just not an expert on it. But anyway, this you can totally do to your phone, of course. Your phone just has some firmware running the operating system, and it has an emergency repair mode in case that gets corrupted, so you can upload a altered image. Now, iPhones have a very complicated system of multiple layers of encryption to stop you from doing this, and this is almost impossible. But Androids don't. You can replace the Android operating system with a modified Android operating system fairly easily, and a lot of people do. In fact, this is one of the most common things people do was put on the special Android ROMs. So I was going to put that in the project, so I started researching it. And there are the old technique where you actually have to download the thing, run some kind of server, put it in special mode, and then there's apps you can put on like this one that will just install it right off the web. It'll download the mod and put it on. And the main one everybody liked to put on a few years ago was Clockwork mod. This was the main one. And the reason you put it on is it would let the interface would look prettier and you could put on special apps and have unauthorized features. Has anybody done this? It used to be all the rage, maybe 3 or 4 years ago. Everybody was hacking their Android phone and putting this stuff on. And as far as I can tell, it's just totally gone out of fashion. The CyanogenMod was the first big one. And then about 4 years ago, they decided to make it a commercial product, and everybody freaked out and screamed and yelled and said, you betrayed the beautiful open source ethic. And so then they couldn't really make any money out of it and went broke anyway. And then they made the Lineage OS, but it seems to just not be going anywhere. I think people just gave up on it. I think they ran out of steam. Another one was Paranoid Android. This was like the #2, really hot. Everybody put this thing on. They said it's the greatest thing in the world. And they also just totally gone broke and given up and died. I think what happened is, I haven't read an article analyzing why, but my impression is Android used to be really super lame, like an Android 2, and so hacking it would make it a lot more fun. And Google finally improved it to where the actual Android is pretty nice, and there's really no reason to do this because the stuff they add sounds pretty dull. Like you make the screen black, you can, it's apparently, there used to be an incentive for this, which is gone because all the groups doing this seems to have just given up and withered away. So I decided not to put it in the projects. You could run this thing in principle and put on alternate ROM, but I didn't see any real point. It was really hot for a while there. It's sort of like, I know a guy that actually buys Macs and takes it off and puts Linux on his Macs to have more control of the Mac, but that's not popular because why would you do that? The Mac OS is actually pretty good. Now, if it was OS 8, I would probably want to do that because OS 8 was a piece of crap. And I think Android 2 is a piece of crap, and that's what drove all this. But the modern one is good enough that very few people, you have to be sort of nuts to do this to yourself anymore, I think. But of course, it might be funny. You just get total control just as a stunt. Anyway, so then there's reverse engineering applications, which is what we're doing in most of the homework in this class. So you've already started doing it. And here's so what you do. You install software on the phone. Then you pull it down with ADB. You can list all the packages on the phone. You can find the path to the APK file for every package, and you can pull it off the phone. So you can get the APK. You can also go online to code repositories and get unauthorized copies of APKs. So you can even get APKs that are not available for your device and not available in your country and everything else. And old versions are all just floating out there. These APKs are all over the place, just like old versions of Windows software. So you get an APK. Now, the APK you can just analyze with a lot of tools, but the best one is APK tool, in my opinion. You can disassemble the thing as we've been doing. This will unpack the APK and get you down to SmallE code. And you can read the SmallE code, but you can also use it as is. This is new this semester. I didn't used to bother with this stuff, but this stuff has gotten very powerful. These vulnerability scanners, I found 2 good ones. Quark and Androbugs are both very good. And this is why I have even less sympathy for people that distribute horrible, insecure Android apps. You don't even need to use APK tool. You could just run a scanner and it would tell you right here in plain English what you're doing wrong. It'll even tell you which line of code is wrong. It's like, you don't need to be a genius. It's like, increasingly my classes are getting less technical because the tools are getting better. You could just run a GUI-based tool that gives you an answer in English. You don't need to read the code anymore. And people obviously aren't even doing that. Anyway, so these programs are ridiculously easy to use, and they give you an answer in relatively clear English. So then this JADX that I learned about from the hacker in France that hacked the Indian website. And by the way, from what I'm seeing, I think he not only hacks the apps, he actually hacks in their server and dumps the data and makes public dumps. Because I think in France, there's no cybercrime laws or something. But anyway, he's, I don't recommend that. But anyway, he motivated me to look at JADX again, and JADX is very nice. You get Java, a nice tree structure directory, just the way a Java developer sees it, right out of the APK file. So you can read Java source code and see what's going on. That's really pretty nice. Now, you cannot recompile the Java source code back into the functioning app, but you can totally read it, and you can search through it to find variable names and secrets and hidden keys and passwords and how they're doing everything and totally decide how to fix it. And then you modify it in SmallE. This is what we're doing. There may be some smarter way, but with use APK tool, you can go in here and just add, like we're doing, a few lines of SmallE code. I only know 3 or 4 tricks in SmallE, and that's enough to have a good time. Yeah.
When you do the logging, where else you find the command line?
Oh yeah, yeah. I just Googled for it. Although, by the way, you can some of them I actually found by just looking at the code. You can go look at somebody else's login code and just see how they do it. What I really wanted to make was a reverse shell. I wanted to post it on Pastebin or open a command prompt. But the problem is opening a network connection is really like 30 or 40 lines of SmallE because you don't have any libraries, and that is pretty painful. Even 2 or 3 lines, I make enough mistakes. I wasn't able to find a SmallE shellcode that I could understand. Somebody could do that. That would be an awesome project. Something smarter than this. Logging is really pretty lame as a proof of concept. I really thought I'd put it on Pastebin. That would be awesome. And I tried to do that, and it was too hard. But I don't even know how to program Java, you know. So what I thought is, I programmed it in Java, compile it, and see how the SmallE looked, and it was like 300 lines of crap. And I said, oh, this is too much bother. But maybe somebody can find like something we can just copy and paste and modify without too much suffering to do something more fun than just put junk in the log. This was just the only thing I could figure out like 3 or 4 years ago when I started doing this. And it's enough of a proof of concept to show that I control the device, but it would be more fun if we totally made a reverse shell, because that's all I know how to do. Very simple. Yeah, that's right. So then you repack it and sign it. It warns you that you're self-signing, which you totally are, and then you run the app. And you cannot put it on top of the existing app because the existing app has the developer signature, and you don't have the developer signature. So you have to remove the old app and put it on a different signature. It will not, remember, Android will not let you update an app unless you have the same signature. So, and we are not using old versions of Android that let us use somebody else's signature. Now that is really disrespectful. If I can take somebody else's code, modify it, and the signature still works, that kind of undoes the entire point. So they patched that. That's ridiculous. So this would mean, therefore, that these exploits aren't terribly practical because the current user base using the genuine app cannot be tricked into using your app unless you social engineer them into removing this one entirely and putting on the next one, which is more of a barrier. But anyway, I got some Cahoots, and then we'll do this offline activity of checking some apps here, and I can start telling you secrets. Do I have a message? I do have a message. Why, thank you. A message. Would reverse shells from Metasploit require the phone to be rooted to work? I don't know. You should try it. In principle, a reverse shell does not require to be rooted. You could have an app that makes a network connection. That's perfectly legal. You would not be root on the device, but you should be able to get a low privilege shell. That's a very good point. I should write down in projects, make a Metasploit APK and put it on. I know they exist and I haven't tried them. It's a very good point. There's a lot of interesting projects to do, a lot of things I'd like to add to this class. That's something to remember. And if anybody's interested, do it without me writing a project. That would be fine too. Come show the class stuff. I know Travis has some awesome stuff to show us. Yeah. There will be any effect other live mobile app testing sessions? I doubt it, but we'll see. We'll see if it's if there's enough interest, you might do it again. We'll see what happens tonight. If it's so much fun we want to do it again, we'll do it again, but maybe not. There's a lot of other fish to fry, so I'm not sure. All right. Anyway, so let's do these Cahoots, which I might even have open somewhere. Apparently I lost them. All right. I tend to do that. Too many windows flying around. All right. Okay, looks like I'm in, and I should have favorites somewhere. Well, that's it right there, 6C. Okay. By the way, the next quiz is up, and the next chapter is up, telling you how many pages it is. The slides aren't up, but the quiz is up. Now, I also cut chapter 7 into 3 pieces. So the first third of chapter 7 is up. That's what we'll do next week. So let's try this. Chapter 7 is where we get the really good new stuff, where we really get into the intention stuff and the internal Android, which I didn't used to know very much about, and I'm learning a little more. So that's a whole nother avenue of Bowne testing, to catch the vulnerabilities where they're mishandling things like broadcast receivers and intents. And I'm hoping to get there, and then we'll probably find that the apps are all broken that way too, because I haven't even known how to test that. And as far as I can tell, the people writing apps don't even know how to do the stuff I knew how to do 4 years ago. So we should have good time with the new stuff. We're missing the music. Oh, the music doesn't start until, oh, it's the music. Okay, good. It's not the same without the music. So. And I'll get something to record the winners in. All right. All right, and this is 128. 12, 212, 213, day before Valentine's Day. Maybe notable for some people. All right. I'll wait another few seconds to see if anybody else is coming in. TKP staying dry, okay. It's not easy to stay dry today. All right, so. All right, so where does the canary value go? Okay, it goes on the stack. That's where, because the stack is where the temporary variables go, and that's typically how you take over a box. And the canary value prevents it by detecting when you are writing beyond the boundaries of a stack frame. And where do double free exploits take effect? They take effect on the heap. All right. How about format strings? What do they attack? Yep. Of course, they get print statements that fail to specify the format string and permit the attacker to feed something which is interpreted as a format string. And what does the NX bit do? Okay, changes permissions in RAM, and you do it on the stack and the heap on sections that you choose that you don't want people executing code on. It does not affect the hard disk. The hard disk has another set of permissions, like read, write, and execute, and all that jazz. NX is permissions in RAM, and on the stack and the heap, and the only one on this list that's right is the stack. So here are the winners. Forrest is a real name. Saul, I don't think that's a real name. Forrest. Saul, and WITB, I know who that is. And maybe they're going to tell me who Saul is. Yes, okay, good. Okay, I'll put that down here. Okay. All right, so I've got that. So are there any more questions? I'm about to close the online part of this. Let's see.
Question about iPhones.
Yeah, just a second, let me check this one. You test the device properly, do an actual man in the middle with hardware. Yes. That's, well, the whole point of testing a man in the middle attack is to not bother importing the certificate. It depends on what you're trying to do. If you're trying to intercept real traffic from an app to analyze it, to debug the app itself, then you would import the certificate so you get through SSL. But if you're trying to detect the error to validate certificates, which is what I'm usually doing, then you deliberately do not import the certificate and you expect the app to complain. And when it fails to complain, that proves it's not validating SSL. So those are the two cases. You could do either one. You could totally use real hardware to be the man in the middle. I'll be doing, I'll add it to the projects after this. That's what I'm going to do tonight. I'm going to use my real Mac as the man in the middle. So for the people online, let me just talk about my setup here. My setup is extremely simple. The problem is it's much harder than it looks because none of this stuff works properly, which is the story for this whole class. It's especially true of this Apple feature. And I'm not used to the Apple operating system running so badly, but this particular part of the Apple operating system runs really badly. And what it is sharing. So if you go to, is it system preferences? Yeah, here it is. This is network sharing. You can do internet connection sharing. You had it in Microsoft Windows since Windows XP, and both in Windows and in the Mac, it doesn't work very well because it has to do with the drivers for your network cards and all kinds of details. So you can share my internet and I'm sharing it out the wireless card. So my wireless icon has changed to this weird thing with an exclamation point in the middle because I am not using my wireless card as a client to connect to a wireless network. I've connected with Ethernet, and I'm acting as the wireless access point. I'm offering a network to people. So people can join my wireless network, then the traffic comes in my wireless card and out my Ethernet. So everybody's traffic has to go through my computer. That's what's going on here. And this way I can test anything, a laptop, a Windows phone, an iPhone, because I'm looking at the network traffic after it has left your device. So I do not need to have root permissions on your device or a special app or anything weird. I can look at the network traffic. Now, this makes the traffic pass through the Mac. And this part is very buggy. And each update in the Mac operating system causes some of these things to quit working. Sometimes you can do it through Bluetooth, sometimes through Wi-Fi, sometimes through neither. It's pretty frustrating. This particular version, I have the latest version of Mojave, I think. Well, actually, I have Mojave. I don't think I've updated it in about 6 months. And it happens to be working for Ethernet to Wi-Fi, which is the most convenient. But each update will randomly break this, in my experience. So if 10 students try it, only 5 of them will have it work for no good reason. Anyway, this is not enough to do the test yet, though, because this moves the traffic through my Mac, but I don't get to see it. What I have to do is route it through Burp. And I'm running Burp here. And to get it to go through Burp, I have to set up the proxy, not only to listen, but also to be invisible. This is called an invisible proxy, where it does not readdress the traffic. The apps on your phone, if you join my network, will not believe that they are 2 hops away from the router. They will not see, they'll just see it, it's going to view the traffic going past without readdressing. That's invisible proxy. And in order to get it to go through there, I have to use the firewall on the Mac. Now, many people don't even know there is a firewall on the Mac because it's not on by default. What they have is some horrible thing called PF. I don't know why they don't have IP tables. That would sure be nice, but they don't. They have some weird thing called PF, which I think is because it comes from BSD. So you have to write this weird thing, RDR pass on bridge. The syntax of this mess is as confusing as IP tables, but different. So you have to do a couple of commands, and I've got a project that specifies these. This is the IPF rule that causes the packet filter to take the traffic coming in the wireless card and send it to Burp, which then forwards it out the Ethernet card. You have to make a file, and you have to do a command line command to run it, and then you can do that. And that's what, it's pretty flaky. Anyway, I wrote it up a previous generation of this class, and I'll put it back up again so people can do it, but many of you will not be able to do it. See, it is possible to do this with Windows too, but it's somewhat painful to set up. And it will depend on your hardware. And so, you know, this is not like most of the projects where most students hopefully can just follow the steps and get to the end. It depends on things that are unfair, like your hardware. We check this chat message. Okay, you mentioned if you want to test the device properly. Yeah, that's right. So, right. Yes, you could probably use Linux to do this in IP tables. Yes, I'm not sure how the internet connection sharing would work in Linux, but I'm sure in principle you can do anything with Linux if you're elite enough. You can bring in some kind of thing and compile it. Yes, probably the friendlier kinds of Linux like Ubuntu Desktop probably have some kind of GUI for this. Yeah, yes, it might even be easy to do it in some versions of Linux by now because they're always catching up with the other OSs. It would be a perfectly good thing to do. And then you can test real devices. Any other questions? Yeah.
What's the difference between the visible proxy intercept?
Yeah, when it's not invisible, it has an IP address. It's listening on an IP address, and you're forwarding data to that IP address, and it then lifts it up to another network like a router. So if you were to do traceroute, your proxy would be a hop. In visible mode, it's not a hop. It doesn't change the TTL. It doesn't readdress it. It just passes it like Wireshark. Just lets it go by. That's the idea.
So does it actually pass it through?
Yeah, you can either configure it to do routing, or it can just do pass through. That's what invisible proxies do.
You just want to grab the data, right?
Yes, you just want to grab the data.
So why can't you do it in intercept also?
For some reason, it doesn't work. I don't really understand why. It has to do with this packet filtering firewall. The red versus blue and the CTDC have convinced me that I don't really understand firewalls very well. Weird things are happening. Firewalls are far more confusing than they ought to be. I don't really know why. Well, I thought I knew them, and then weird things happen to convince me that I don't really know them.
You don't care about
I have to really have Wireshark on both ends and follow the packet completely to find out what's going on. I don't really know the answer to your question. If you figure it out, let me know. Anyway, all right, so that's what I've got. We're going to test stuff here, and I'm going to show you some bones I found that I can't advertise publicly. But I'm going to stop the share unless we got any more questions from the online people. All right, I'm going to do that. Let's take like a 10-minute break till 7:15, and then we'll come back and do this